Hey y'all, I just wanted to do a quick demonstration of what happens if we have an inclined plane and a mass on it. How do we sum the forces? How do we get the equations of motion? Because I don't think the book goes over it. So here's our inclined plane at some angle theta. Let's say we have some mass on here. And let's say maybe there's some force that's going parallel to the plane. If that force is pulling it up the plane, we might have some frictional force right here opposing the motion. The tricky part that people end up making errors on, though, is we need to take this mass center. The first thing I do is draw mg down. Alright, now we want to break up things into parallel and perpendicular components. So I'm going to draw a perpendicular through the plane and then make a parallel over to it. Now, this thing right here, if this angle becomes theta, which it does, becomes mg cosine theta. It's a component perpendicular to the plane. And the component parallel to the plane would be mg sine theta. So a lot of people automatically go and think that this is x, so go with cosine. That's not the case. The y or perpendicular direction we should think of is cosine theta, because this becomes our angle theta, not this. Alright, so the next step would be summing the forces. Okay, if I sum the forces in the parallel direction, that would be up and down the plane. So in this direction, I get some force pulling up the plane. And we can get rid of the vector because we know which direction it's going. I get a frictional force opposing it. And then what else we have? We got this thing right here, and it's opposing the direction. I'm going to call up positive like that. Even if I think it's going to go down the incline, I'm going to call up the incline positive. So this becomes a minus mg sine theta, and that equals mass times the acceleration in the parallel direction. We expect some acceleration in the parallel direction. So there's one equation of motion. And the frictional force could be found by taking the normal force and multiplying it by the coefficient of friction. So you'd have to find the normal force in this case, and you do that by summing in the perpendicular direction. Okay, what do we have in the perpendicular direction? We have, whoop, I forgot the normal force. There we go. We have a normal force pointed up. We have this mg cosine theta pointed down. And that's it. That equals mass times the acceleration in the perpendicular direction. Now we should compare if there's any lifting force. For instance, if F lifted up, it would alleviate some of that frictional force too. That would all come out of the problem though, automatically. But make sure that it stays on the surface, and then we can say that the acceleration perpendicular is 0, meaning the normal force is equal to mg cosine theta. And then we plug that into there and that into there. Now we have acceleration, because we'd most likely be given the force. We know the mass, we know the acceleration due to gravity, we'd be given angle theta, we just calculated the friction, and once again we know the mass. Alright, 2 equations, actually 3 equations in this one. Be very familiar with this. Make sure you don't swap those two things.